The next thing we're going to take a look at is determining where the implicit function that I just gave you, 4x squared plus y squared minus 8x plus 4y plus 4 equals 0, has a horizontal tangent or a vertical tangent. Remember, horizontal tangent, tangent line that's going to look like that. Vertical tangent, tangent line that's going to look like this. I'd like you to copy down the problem. Do not yet go to Desmos. Just copy it down, and the video is going to pause if you're watching an Edpuzzle. Well, the first thing we're going to have to do to make sense out of this is find the derivative. So we're going to go find the derivative of 4x squared plus y squared minus 8x plus 4y plus 4. We'll also find the derivative of 0, but that should be really easy. How about you take a moment, go find your derivative, and Edpuzzle will pause while you do that. Derivative of 4x squared should be 8x. Derivative of 2y is 2y dy dx. Derivative of minus 8x is minus 8. Derivative of 4y is plus 4 dy dx. Derivative of 4 is 0. Derivative of 0 is 0. I'll move my terms without a dy dx to the right just because the dy dx are both positive, and I kind of like positive numbers over negative numbers. Dy dx, 2y dy dx plus 4 dy dx equals 8 minus 8x. I'm going to factor out my dy dx. I'm going to get 8 minus 8x. Dy dx equals 8 minus 8x over 2y plus 4 is my derivative. Did you get that, or did you get the version where you could factor negative 1 onto the top and bottom and get the same thing that I had? Hopefully you said yes. Now, horizontal tangents. Those occur when the derivative equals 0. If a fraction equals 0, what part must equal 0? The numerator, the denominator, or both? Well, if both equal 0, it's undefined, and that's not going to help us get anywhere. That means factor and cancel, all that stuff. But if our derivative is 0, that means the numerator has to equal 0. So I'm going to set the numerator equal to 0. I'm going to get 8 minus 8x equals 0. 8 equals 8x. X equals 1. When x is 1, I'm going to have some horizontal tangents. Now, I need to go and I need to plug 1 back into my original formula to try to figure out my y value. I'm going to get 4 times 1 squared plus y squared minus 8 times 1 plus 4y plus 4 equals 0. This looks like 4 plus y squared minus 8 plus 4y plus 4 equals 0. Y squared plus 4y equals 0 is what I'm getting. It's a quadratic equation, which means I'm going to get two different answers. There are going to be two places when x equals 1 and I have a horizontal tangent. I'm going to factor out a y, get y times y plus 4 equals 0. Y is going to equal 0 and negative 4, which means I have a horizontal tangent at 1, 0 and another one at 1, negative 4. And when we're done with the entire problem, you're going to go to Desmos and check to make sure that's really what's going on. I'm going to make the video pause for a moment just so you can get caught up if you were a little behind. Now we need to focus on our vertical tangents, and actually you're going to do most of this work because it's going to work out in a very similar way. Vertical tangents occur when the derivative, when the slope, is undefined. And for a fraction to be undefined, that means the denominator has to equal 0. So, your first job, set the denominator equal to 0, and tell me either the x or the y value where that happens. Hopefully you're telling me y equals -2. Now, go plug back into the original, find the x values, and when you're done, I'd like you to tell me the coordinates of the points where we're going to have vertical tangents. I guess this is going to become another GCF thing. Just realize if that wasn't the case, you'd have to factor using other techniques that you know. So hopefully you told me the answers were 0, -2, and not negative, and 2, comma -2. Go to Desmos, check it, make sure there are horizontal tangents at 1, 0, 1, -4, and 0, -2, 2, -2. Hopefully that graph was actually something that looked familiar from last year in pre-calc or 2 years ago in Algebra 2. It's really just the graph of an ellipse. We could complete the square with this original thing to turn it into our standard ellipse form. But yeah, we should have horizontal tangents there and there, vertical tangents there and there.